Okay. We want to keep talking about the number of elements in a set. And so yesterday we worked more with just shorter problems. Today we're going to look at more like applied problems. So it says a survey of 100 coffee drinkers found that 70 take sugar, 60 take cream, and 50 take both sugar and cream with their coffee. How many coffee drinkers take sugar or cream with their coffee? And so when they give you a problem like this, you want to define it mathematically, okay? So we're going to say we're going to let the universal set be the set of 100 coffee drinkers that were surveyed. And then you could call it different letters if you want, but we want A to be the ones that take sugar, but they have to be from the set. So here's a nice way of writing that. We can say, oh, that's really blurry, isn't it? We can say that X is in the universal set and with the restriction that they take sugar. So of the ones surveyed, they take sugar, and that's the math way of writing this. So now we can say that B represents, again, X represents the ones in the universal set that also take cream. Okay, so remember from yesterday, if we want to know how many take sugar or cream, then we're kind of asking for the intersect. No, we want the outside part, don't we? Okay, sorry. I'm going to draw a Venn diagram. And then we'll go from there. I like to do it picture-wise, but then we can also talk about it equation-wise. So 50 take both sugar and cream, right? So this is A, this is B. 70 take sugar, but if 50 take both, that just means 20 is left out here. And 60 take cream, but 50 take both. So that would just be 10 out there, right? 50, 60, 70, 80. So what does that mean? Well, there's 20 out here that don't do sugar or cream. Do you agree with that statement? So the question is, how many take sugar or cream? That would be A union B, right? Number in A union B. And we can see from my lovely picture here that it would be 50, 60, 70, 80, right? So 80, I believe, is the answer. How could you do it without drawing the picture? Well, remember that we can take the number in A plus the number in B minus the number in A intersect B. So we could have taken, gosh, I have to look back up here. 70 take sugar plus 60 take cream minus the 50 that do both, and we're going to still get 80. So we have the equation way, we have the Venn diagram way. What if they asked us to find the union of three sets, like A union B union C? What do you think we would do? Well, definitely I think the Venn diagram would be helpful to figure that out more than the equation. Because we would want to not double count all these, right? So we would have to subtract not just A intersect B, but we'd have to subtract out all these. So I think that we would get the number of A plus the number in B plus the number in C. That would be like this, like X, Y, Z, like the total numbers, right? But then we'd have to subtract out all these guys, all these intersections, right? So we're going to subtract out the number in A intersect B, the number in A intersect C, the number in B intersect C. So that would be these guys. But then we also have to subtract out the number in A intersect B intersect C. And this is where I would probably not do it equation-wise like this. I would do it with a Venn diagram, and that's what the next couple examples are. So again, I just took this from your book, but it says a leading mobile phone service provider advertises its services in 3 magazines, Cosmopolitan, People, and Time. A survey of 500 customers by the mobile phone service provider reveals the following information. And so like 180 learned from Cosmo, so many from People, so many from Time, and then so many from both Cosmo and People, Cosmo and Time, People and Time, and then 38 from all three. So it says how many of the customers saw the manufactured advertisement in at least one magazine and in exactly one magazine. And this is where if we could draw the Venn diagram, it's going to make life a lot easier, okay? So I'm going to double page this. I gave you a page here with a Venn diagram so we could kind of fit it on here nice without you having to draw it. Again, we have to denote what letters we're going to use. So again, the universal set would be all the customers surveyed. And then this time we actually use letters that kind of make sense. C for Cosmo, P for People, and T for Time. And again, when you're naming your sets, you have to say that X is part of the universal set and then the restriction from there. Okay, so I'm going to double page this, and then we're going to kind of make a tiny Venn diagram on my paper. So this is going to be C and P and T. And then I'm going to write the numbers here. So what do we know? We know 38 learned from all three magazines. So that's where I'm going to start first. Like 38 is going to go in here. So to me, you have to fill in the overlaps first because that way you can do the 180, subtract that, right? So we got the 38. 64 learned from People and Time. So People and Time is 64. Can I put 64 right here? No, because that also includes the 38, right? So you have to take 64 minus 38 so that together that's 64. I'm not trusting my math skills. So that would be 26. 52 learned from Cosmo and Time. So Cosmo and Time, 52. So I have to take 52 minus 38. And I get 14. And then 84 learned from Cosmo and People. So I have to take 84 minus 38 to get 46. That's a 4, not a 9. And then from there, I can do 192 for Time. But Time already has all those three numbers in there, right? So for Time, I'm going to take 192 and I'm going to subtract 14 and 38 and 26 from each one, right? And I got 114. And I'm going to do the same thing for the other two. So People had 200. And so for People, I'm going to take 200 minus 46 minus 38 minus 26. And I get 90 left over. And Cosmo had 180 altogether. So again, I'm going to subtract from all of those. And I think that I get 82 on that. And here's my universal set. My question is, does that add up to 500 customers? 82 plus 46 plus 14 plus 38 plus 26 plus 90 plus 114 adds up to 410. So there's 500 altogether. So that means there's 90 out here. Okay, so that's always something to think about. Okay. So that takes some time. Once you get that figured out, that's why on these questions and the problems from the book, if they give you A, B, C, D, it doesn't matter because once you draw the picture, then it's just digesting it all, right? So it says, how many customers saw the manufacturer's advertisement in at least one magazine? Well, I kind of figured that out already because at least one magazine would be any of those. Do you agree with that? And what would that really be? At least one magazine would be the same as saying like the number in Cosmo, Union, People, Union, Time. At least one, right? One or more. And it's 500 minus 90. Like it's 410 people. And then what about part B? Exactly one Well, exactly one's going to be, that's a lot weirder to write, but let's practice writing it out. Exactly one would be, I want it in Cosmo, but not in the others, right? And so I think that would be, I want it in Cosmo intersect P complement intersect T complement, because that's going to take out the 90 on the outside. And that would just be 82. And then I would do the same thing. If I want just people, then I would do Cosmo complement intersect time complement. And that would be 90. And then if I want just time, that would be intersect Cosmo complement intersect people complement. And that would be 114. And then I'm going to add those all together, right? So if I was going to write that expression out, I would write all that together. And so I'm just going to take 82 plus 90 plus 114 and get 286. So again, we want to be able to draw the Venn diagrams. We want to be able to write it out as well. Okay? Okay. Let me undual page this. It's going to look really gigantic now. And then this is the last one. And we're going to do this one, like finish this one in class, but this is where they give you 3 and they give you a ton of information and see if you can fill this out, especially based on the one that we just did. So it says sets A, B, and C are in the universal set U. So we have our universal set U. We have A, B, and C. And they give us all this information with all these intersections and complements. And they tell us the number in A is 22, the number in B is 46, and the number in the universal set is 156. So I'd like you, maybe in pencil in case you mess up, try this and see where you can get, and then we'll start here in class. Okay?